Alright, so today we'll finish off the chapter with the law of cosines. Now the law of cosines you want to use with triangles where you know the two sides and the included angle or all three sides. Okay, so we'll go over each situation first. So let's find the actual. What we're also going to do is go over Heron's formula, or Hero's formula, and this deals with triangles where you know all three side lengths, and you can actually find the area of the triangle by using this formula, but we'll talk about that in a sec. Now let's notice some similarities here in this triangle, or in this formula, okay? Some interesting stuff. This first part looks like Pythagorean theorem, and that's because it pretty much is the Pythagorean theorem, except a little bit tweaked. Okay, so those two definitely look like Pythagorean theorem. So that first part shouldn't be too hard. This second part, okay, it's always going to be a minus. It's always going to be a times 2, and it's always going to be the other two sides. So that's also important too. But it's also, here's an interesting thing. The first side and the angle are going to be the end caps for this type of problem. Okay. All right. So everything's all set up right here to where you need it. So if you're trying to find B, you would use this formula. If you're trying to find C, you would use this formula right here. Okay, so everything's all set up. Let's actually draw out a triangle that will work with this. Alright, so we have our triangle right here. It's got side B is 9, side C is 5. The angle A is 120, and we don't know side A. We also don't know angles B and C, so we'll actually figure out all the missing three sides, or the missing side and the missing two angles. So here's the cool thing is when you're using law of cosines, you technically only have to use it once. You could use it like a couple of times and stuff, but technically you only need to use it once to find a missing side, and then you could use law of sines from there on out. Okay, so it actually is pretty cool. So we're going to use this one up here. So we're going to use this formula right here. Okay, so we're going to use this one right here. Now if you're using a different one, obviously you would use a different combination of A, B, and C. So I have A squared, I plug in everything, equals 25 plus 81, because those are both respective squared, minus 2 times 5 times 9 cosine of 120 degrees. Oh, times. I need to have the times here. My bad. Okay. Alright, now when simplifying this, you could literally just put that into Desmos and just have it as is. Just put in a calculation and you're all set. So we would have 25 plus 81 minus, and you would definitely need the parentheses, 2 times 5 times 9 times cosine of 120. Okay, and that would be 151. Is that right? 120, yep. Okay, so that means A squared equals 151. Okay, now you would still need to square root both sides. Okay, so that's pretty simple. And obviously when we're doing square root, you're going to be thinking of just the positives. So we do square root of 151, and we get 12.29. Okay, and that's going to be the side length right there. Now what I would probably do to finish out solving for the angles is I'd probably use law of sines to actually get there. So I would have sine of 120 degrees divided by 12.29, and then I would set it up accordingly how I wanted to find the sides. So I feel lucky. Let's go ahead and find angle B first. Okay, so sine of B divided by 9. Okay, so we do our cross multiplication. Well, technically all you need to do is get rid of times by 9, or divide by 9, and so we should have 9 times the sine of 120, okay, divided by 12.29 equals the sine of angle B. Okay, and then on this one you would do arc sine, and this is going to be tricky because you're going to have some double stuff in here. So it'd be 9 times the sine of 120 parentheses, divide by 12.29, parentheses, and this would equal angle B right here. Okay? So, so that's 9 times sine of 120. Get it. Okay. Okay, so we do arc sine of 9 times sine of 120. Probably put that in parentheses. Okay, and then we divide that by, what was it, 12.29? Yep, 12.29. And we should get the actual angle measurement to be 39.36. 39.36. Okay, now, since I know this is now 39.36, I can use some logic here. I know that this is the biggest combination because that's the biggest side opposite the biggest angle. This is the medium side opposite the medium angle. This has to be the smallest angle when I do the calculation. So when I subtract everything from 180, 39.36, I should get a really small angle, which is actually turns out to be, and I don't even need to use law of sines or law of cosines to finish this off because I just use some great logic from mathematics, and it's going to be 20.64. Okay, and so by using the sum of the interior angles of a triangle, I can finish that off. So technically, all I need to do is use law of cosines once, law of sines once, and then the rule that if you subtract the other two angles from 180 degrees, you should find the third missing angle, and it all works out. Okay, so this is just a beautiful situation. Now, if you'd like to check your work, plug it into the law of cosines, see if you get a number on both sides that is equal. Okay, so you just have to be very careful how you work with this stuff. Okay, now this one is where you're given all three sides and you need to find a missing angle. Now, my recommendation, and this always works, is find the biggest angle first. Now, using the triangle inequality theorem, the side opposite, or the angle opposite the biggest side, is going to be the biggest angle. So I'm going to find angle B first. So that means my theorem is going to be B squared equals A squared plus C squared minus parentheses 2 times, oh, I got all kinds of capital letters, I don't want that. Okay, B squared equals A squared plus C squared minus 2 times A times C times cosine of angle B. Okay, now in this situation right here, we're going to be solving in this equation, we're going to be solving it for angle B. So I'm going to plug in everything. So this is going to be 40 squared, which is 1600. And let me see, A squared is going to be 24 squared. So 24 squared is 576. Okay, 18 squared is going to be 324. Okay, and then we're going to minus, all right, 2 times 18 times 24, and that's going to be 864. 864 cosine of B. Okay, so I have all my numbers set up. Now here's the thing though, is that most people will add all three of these up and then divide it and then try to do cosine inverse. You don't do it that way. Please don't. The only two you're going to add are these two, because this is 864 times cosine of B, and I don't see a cosine of B over here, so they're not all like terms. So this becomes 1600 equals, and let's let me see, 576 plus 324. Oh, nice. 900 minus 864 times cosine of B. Okay, so I'm going to minus 900 from both sides, so I should get 700 equals negative 864 times cosine of B. Okay, now I can divide both sides by that negative 864. Okay, and so I'm going to go negative 700 divided by 864 equals cosine of b. Okay, now I can do arc cosine to both sides. So arc cosine of negative 700 divided by 864. Now some of you guys are probably wondering, wait, where'd you get, wasn't the 700 positive and the 864 negative? Yes, I kind of, when I divide, I like to keep the negatives up top, so it doesn't matter that you switch it from one to the other. Okay, so we go to our calculator, and we go arc cosine of negative 700 divided by 864. And we get 144.11 degrees. So 144.11 degrees. Okay, and then from then on out, you can use law of sines to figure out a missing second angle, and then you could use the rule of the sum of the interior angles inside of a triangle are 180 degrees to figure out the other part. But my recommendation to you always, and this is just a trick I learned from my trig teacher, is find the angle that is the biggest first when you're doing SSS with law of cosines, because it will all work out a lot easier, okay? Alright, so in this situation, we're going to find the area of the triangle if the side lengths are 4, 7, and 9. Okay, now if you remember in Heron's Hero's formula, you got to find S first. And S is going to be 1/2 times all the sides added up. So 4 plus 7 plus 9. Okay. And so I go 0.5 times parentheses 4 plus 7 plus 9. And that will be 10. So S actually turns out to be a nice number, which is 10. Okay. Now the actual area formula is the square root of all of the S times S minus A times S minus B times S minus C. Okay, so I'm going to plug in everything right here. So S is going to be 10, so it's going to be 10 times 10 minus 4 times 10 minus 7 times 10 minus 9. Okay, so I plug that into my calculator as is. So when you're plugging it into your calculator, make sure you have parentheses in the correct spot. So I do square root of 10 times 6 times 3 times 1. Okay, and I get 13.41 as the actual area. Alright, so when you guys are doing this stuff, make sure you just take the time to recognize the fact that you need to find S first, and then you need to do the calculations as is. And you can put them all in at once, or you could do a calculation on each one each time and then square root the very end. It's up to you, but find S first and it will help find your area, okay? Alright, that's it. I'll talk to you guys later. Bye.